This next project is a simple project to demonstrate electrostatic forces, and what I have here is two styrofoam spheres or balls that I've coated in foil. You can see them here. Here's a close-up of it. It's coated in aluminum foil, and this is a very thin aluminum foil that you get on the Lindt chocolate bars. It's very, very thin. The regular baking foil is probably too heavy for this. So you want these styrofoam balls and coat them with some thin aluminum foil, which you can typically find on chocolate bars. And these are about probably just under an inch in diameter. I have some plexiglass, and I have some adhesive aluminum foil, and I've arranged it in this array, as you can see here. The whole area where the balls are going to be in action is enclosed by this plastic frame, which is made out of coat hangers that I've cut and then joined together by melting the ends and pushing them together. And the voltage is applied here. I'm going to apply about 20 kilovolts over here, which comes from a Cockroft Walton multiplier. It's about 20 kilovolts, and I'm using a capacitor which I've made from a bottle, and that's in one of my earlier videos. This bottle is coated in both inside and outside parts of the plastic bottle are coated with adhesive aluminum tape, and this is liquid electric tape here. And this thing will store anything up to 50 or more kilovolts, so it's got some pretty good capacity. And as you can see, the ball is doing nothing, and we're going to activate the whole circuit by connecting the multiplier to a sealed lead acid battery. I have a 12 volt battery here, and I have an inverter. This is 12 volts DC in, 950 volts AC out, which is then amplified to at least 20 or more kilovolts by this multiplier here. So here we go, and I'm about to connect the lead, and just as I connect it, let's focus on those two spheres to see what happens when we connect it. Here we go. Whoops, there they go. And they hit each other. They shorted when they hit each other. I can disconnect this and they'll keep going because there they go. They shorted out the capacitor. So let's briefly touch this just to charge up the capacitor enough to get them moving. There we go. It's not connected, and they did short again. Let's do it again. It's like a battle game as they hit each other and short out. Let's do it again. There they go. They repel each other when they're light charge. This one has actually knocked itself right out. But when they're opposite charges, they'll attract. There we go. Let's briefly touch this to the battery. Now let's just try it with one sphere. See what that does. See how long that'll go for. Here we go. And that's just on the charge that's in that pill capsule or tablet capsule bottle there. Whoops, okay. It will go for quite a long time in a totally random motion. Let's add 2. Now get it going a lot longer if you have 2. I mean, a lot shorter if you have 2 of them. This makes a nice toy, but would have to be for someone that's a lot older that can understand the dangers of playing with high voltage electricity, because you do not want to take a direct hit from that capacitor. Eventually they'll make contact and short out. This project's based on work that was done by Thomas Kim, and you can find a similar project in his videos. He uses a hand crank to generate the power, hand crank generator, but it's a similar kind of setup. And probably similar materials. I mean, I'm using adhesive aluminum and a hanger, a bunch of hangers that I've cut up to make this, and the plexiglass. But pretty much, you know, any household material will work with this thing. And all of this is all household materials. The only thing that you would need to purchase would be the diodes, which are 1N4007 diodes, and a bunch of 6 kilovolt capacitors. Those 100 picofarad, and you can buy an SLA battery or just use a power source. And these inverters, which are cold cathode drivers, are about $10 or less each. You can get those off of eBay.